So currently for 2021, that was about 405 of the available stations. And as you can see over on the chart on the right, every year we seem to be gathering more and more stations. Currently, we're computing this using the Bernice GNSS software 5.2, and it depends on the IGS final combination as our a priori input. So it's consistent with the final combination. We do attempt to fill in any missed stations, and every once in a while I get an email from somebody who is interested in a station that we missed, and if possible, I'll go back and reprocess those to fill in. Sometimes the data is not available though, and there's nothing I can do. I can't simulate the data. The download location is, the link is right there. It's on CDDIS. That's the full link. I won't read it for you. Next slide, please. So our progress since the virtual workshop in June is we are updating to the IGS 20 reference frame in the Repro 3 models. This is estimated to happen next Sunday, so it's going to be consistent with happening on GPS week 2238. It is dependent on the IGS finals, as I told you, so if those are not available, we will be unable to update at that time. And then also coming very soon is a switch to the new long format file name to match the IGS products that just made that switch. This is based on the Troposphere version 2 file, and there you can see the new format and the old format as well as an example. I nicely picked a USNO receiver to give you for an example. But if you want the full file name details, the link right there is where you'll find them. All right, next slide, please. More work that's in progress. We are going to be updating to the new Bernice software 5.4 in the very near future. I estimate that to be in the next 3 to 6 months. Hopefully that'll be a seamless transition for the users. We're also currently working with CDDIS very slowly, but working with them to get the README files and the Troposphere directories either updated or in place, as there's many directories with very little information as to what's in those directories and which one's the official one and which one is old and what it was. So that can be confusing to new users who are unfamiliar with that structure. And then finally, we're going to restore our archive on the USNO web server. As many of you may remember, our web server, Maya, went down unexpectedly a couple years ago. It has been restored to service. And so we are now going to backfill the archive, but CDDIS is still the official location for the estimates. Next slide, please. And then here's our recommendations that came out of the workshop for future work, things that we're moving forward on. The Repro 3 computation. Those will be estimated soon, and I'll probably send out a few test files for people to look at before I go back and do the entire Repro 3. We're also in the process of testing new troposphere models in the final estimates. We're currently using GMF. There's talk in the group of using the new VMF model, but there's some issues with the discontinuities between the 6-hour releases. So we'll take a look at those as well as investigate other models as well to enhance our estimates. And then finally, as part of the strategic goals of the IGS, we are going to look at multi-GNSS estimates. So again, we'll probably put out test estimates to everybody to take a look at before we decide what is the best route to go. We'll probably put out a few different methods of computing these, either in combination with other GNSS constellations or compute them individually. We'll see what exactly makes sense for our product. Next slide, please. Oh, that's it. So thank you guys for your attention. There's my contact information if you want to get involved or have any comments or questions.
I have a question.
Sure.
I'm Olivier Bock from IPGP IGN. You mentioned Repro 3. I was wondering if you consider using the products or reprocessing with the Repro 3 satellite orbits and clocks.
Yeah, we're going to use the Repro 3 combination and reprocess.
So you are planning to do a reprocessing? Yes.
Yes, but it will be and a separate directory in CDDIS, so it's not confused with the operational product.
Okay. Yeah, thank you.
One slight follow-on question. Hi,
Sure.
Jonathan Jones from the Met Office. Do you have any timescales on when you estimate that will be complete, the Repro 3 Tropo products?
That's going to take a little bit longer. I'm kind of waiting on the software upgrade, so that I'm not muddying the water of a product that goes across software. But as soon as that's in place, that'll probably be one of the first things that we start with it.
2023.
Yeah.
Okay.
Harald Schuh from GFZ Germany. How do you compare with other techniques like Doris or VLBI?
So we have a troposphere comparison website that Jan Dusa created. There was a link on the IGS troposphere working group page, but we've lost that link and we need to put it back up there. But it depends on the technique and the time series that you're looking at. But that comparison website allows you to go in and check out the different ones that you're interested in. So I don't have any specific numbers because it's different for each one. So any other questions? Felix?
And I was wondering if you would have an interest in using the products, the Repro 3 products, the analysis centers have already provided, because instead of reprocessing everything, maybe using those products that already exist?
We could. The way we process now is in a PPP, so we need a single a priori value to put in. So we could look at doing a combination of the analysis center's estimates if that is something the working group would be interested in. But the current plan is to do the PPP for the combination product. But it would also be interesting to take a look at the comparisons between the ACs and that. So, yeah, thank you.
Thanks so much. I mean, we need to switch to the next presentation. Thanks again, Sharyl. So the next talk is on the antenna working group, and it's given by Arturo online. Arturo Villiger online. Arturo, are you with us?
Thank you. I will like to give a quick overview over the status of the antenna working group and give a small outline what I think will be one of the next challenges. So the first one is what was achieved in the year 2022. Well, of course, the biggest achievement was the transition from the IGS Repro 3 Antex to the IGS 20 Antex in collaboration with Paul. This also means basically for the users, as of now, we have now the IGS 20 out, is that the official IGS Antex file is no longer the IGS 14. However, it is now the IGS 20 Antex file. We will also keep updating the IGS 14 and the IGS 20 Antex for a while until we will stop to provide the IGS 14 Antex. It's not yet decided when. Then I would also give some overview of the project ring antenna calibrations. And last but not least, just to give some ideas, what are the next topics which we need to address. Switch that off. So basically, first I want to give a few words about the IGS transition from the IGS 14 to the IGS 20. As was mentioned, starting from GPS week 2238, we switched from IGS 14 to IGS 20. Therefore, now the IGS 20 Antex file is the current IGS Antex file. Nevertheless, we will continue to provide both files, IGS 14 and IGS 20. The modifications when we do modifications concerning the satellite constellations will be communicated through the IGS mailing list. Note that in case we just do some updates, which includes receivers only, those messages will not go to the IGS mailing list. However, we will just send them to the IGS equipment mailing list. For the IGS 14 Antex, it will still be kept updated. However, I will not send mails around it when this is updated. For the transition from the IGS 14, basically was a two-step. We first had a step transition from IGS 14 to the IGS Repro 3 Antex file, where we introduced the Galileo-based phase center of space, we introduced the Galileo scale. We added multi-GNSS robot and jumper calibrations receiver antennas, which included all systems. After that step, once the IGS-20 was released, we had adapted the IGS R3 Amtex files and therefore also the scale, so it's compatible with ITRF 2020. And this basically means that the values for the set components for the GPS and GLONASS satellites have been re-estimated. For the GPS Block 3A satellites, where the phase center offsets have been disclosed, they have been adapted accordingly to be basically compatible with the ITRF scale. The same is valid for the Galileo. There we had to make an offset change for the set components again to have then the ITRF scale. And in addition, compared to IGS Repro 3, we also have updated the multi-GNSS receiver calibrations where they were available. And from this moment on, as it is now out, the multi-GNSS calibration will no longer be modified, and we will just update by adding new antennas, but the old values will no longer be changed. To give you a quick overlook what has changed between the IGS 14 and the IGS 20 Amtex, basically. In the IGS 14, we had the situation where we had for GPS and GLONASS L1, L2 antenna calibrations. For GPS and GLONASS, the offsets and calibration have not been available. Galileo was officially not yet part of the IGS 14. For the IGS 20, we now have multi-GNSS calibrations. GPS satellites are still estimated. Nevertheless, for the GPS Block 3A, there we have adjusted at the scale, and the same is valid for Galileo, where we have the jumper calibrated values and the Z component is adjusted accordingly. And this is already the short overview of the IGS 20 Amtex, which is now active. And the second overview I would like to give about the project and the goal of the project ring antenna calibrations, which have been passed by Tobias to me. So early this year, we have transferred the lead to Andrea, Villiger, Igor, and Tobias, which are now taking the lead for the antenna calibration, ring antenna calibration project. And the main goal of this project is basically to finding causes and assessing the difference among the calibration methods, improve the stability and reliability of the phase center corrections, and consideration of further parameters in calibration process and definition of uncertainty values of the phase center calibrations. And maybe I have just to mention the idea is of this project that we have several antennas which are sent around for all the calibration facilities so that we can compare actually the values and see how well they fit together. The project basically started in September, sending antennas around. We have 8 participants from 6 countries, which is very nice, so it seems it's quite global distributed. We have 2 jumper calibration facilities and 7 field robot calibrations. And there will be around a total amount of 6 antennas which are sent around and calibrated, where 4 of those are choking antennas. We have 1 geodetic and 1 rover antenna which send around, and then we can compare the values. And this is the current status about the project ring antenna calibrations, and I'm looking forward to see the results of this effort. And this is already come to my last slide. This is kind of the outlook, which I see, which is important within the IGS community, and it's particularly for the antenna. Of course, we need the continuation of the ring calibration project. We will continue to update the IGS 20 Amtex and also the IGS 14 Amtex for the ACCs, but also for the users. And one of the topics will be the extension of L5 for GPS. We also need to study the impact of multi-GNSS calibrations. So currently the IGS, mostly the ACC, relies on 2 frequencies. The question is how well do the calibrations of all the other frequencies work together? We need to work of the inclusion of Beidou and QZSS in terms of the antenna calibrations. How well do they fit with the ITRF? And try to push them so they can contribute to the next ITRF solution. And last but not least, but I will not go into detail, we also need to study the origin of the scaling consistencies between Galileo and the ITRF. So where does this come from, by looking at all possible causes of this. With this, I would like to end my presentation. And if there are any questions, I would like to answer them.
Tom?
This is Tom Herring from MIT. Arturo, one of the main antennas used at the legacy GNSS network sites is the Dorn-Margolin AOA antenna. And if there were a L5, E5 calibration for that antenna, would that be added to the IGS 20 antex file at the moment, or is that going to be left until the next reprocessing?
I think we need to look at this in particular within the antenna working groups and the ACs to see if that is feasible. I can imagine that we could think to extend the patterns as long as we don't change L1, L2. So I think the most important part is that we don't change L1, L2, which are now used also for the reprocessing, and this we cannot change, but adding another frequency, I think this is possible as it will not have an effect.
I think that would be very useful.
Again, more questions? Do we have questions online? No?
Questions online?
No questions.
Okay, so thanks again, Arturo. And let's move to the next working group, which is on clock products with Michael Coleman.
All right, welcome everybody. My name is Mike Coleman. I'm the chair of the Clock Products Working Group. I work out of the U.S. Naval Research Lab in Washington, D.C. So I've been the chair of this group since about 2014. But the group itself has gone back almost 2 decades now. It was originally formed following a joint pilot project between the IGS and BIPM, which was working on finding ways to resolve accurate time and frequency comparisons by using GPS phase and code measurements. At that time, once a lot of their work was sewn up, and it was found that the continuation of products was valuable for doing clock comparisons, the working group was formed in order to maintain those products and also have ways to look at making improvements for them in the future. So that's largely what our role is now, is to work with the analysis center coordinator, developers of any combination of software, the analysis center representatives, to ensure that the core products are meeting the necessities that we expect from the IGS. We also are responsible for consulting the governing board and the IGS in general on any issues that are specific to clock sort of timing infrastructure, or any kind of timing issues in GNSS or in the IGS network. In 2019, we updated our charter to set the goal more towards multi-GNSS clock products. The original charter had been mostly about GPS, as that was the focus back in 2003. We also updated our membership to emphasize participation from lots of different elements of the community. So the membership presently involves, in addition to a number of members from the CB, we also have the analysis center coordinator, is always a member of this group, since it's just such a critical part of the development of the core IGS products. On a daily basis, the rapids are formed both by the orbit combination and the clock combination, and in the background, there's also a re-referencing of the IGS time in order to take out the combination reference and minimize the day boundary jumps from one day to the next in the clock product. So the ACC is a very important member of our group. We also have representatives from the BIPM, given their role in the development of UTC. And we also have a member from each of the analysis centers that produce clock products. Something I codified in the recent charter was also to make sure that we are keeping members from different UTC-K centers, those who were involved in providing accurate reference time and also are part of the IGS network, so that it would help to maintain links to UTC. I've also had a note in there to have up to 6 at-large members from anywhere in the associate membership list. So anybody who's feels they can contribute or has specific needs they could address to the working group, who feel they would be valuable on the working group, can always contact me to seek membership in this group. I personally have up to 6. I haven't really had too many people come to look for that, but I'm sure that number could be updated to higher if it were needed. So I'm going to go through a number of the things that we've been working on over over the past year. They kind of vary in flavor a little bit. As I mentioned, one of our goals is to make sure that we keep the IGS products running on a daily and weekly basis for the finals, the rapids and the finals respectively. Those currently sit at an RMS for, at least with GPS, around about 20, 30, maybe 40 picoseconds, depending on the satellite. What you're looking at here are some of the results that have come out of the new clock combination out of Wuhan and PPPAR. And it shows that there is considerable improvement in some of the estimation, the picoseconds. The RMS is now in the picoseconds of just under 10. And that's largely the same for GPS and Galileo. It's a bit more scatter in the convergence solutions for GLONASS. And we do expect probably we would see improvement over time in the Galileo solution. You're looking at about 3 years of reprocessing here. This is part of the Repro 3 effort. We brought it right up to 2020. This has been in conjunction with some of the work I've also been doing to rerun the IGS reference time. The reference time is being generated by some new software that we've developed at NRL to help improve the robustness of the ensemble, so we don't have to make as many corrections as we've had over the past couple of years. Certain anomalies that have gotten in the way and caused things to jump or run off. One of the things we've noticed here is that the day boundaries are considerably noticeable in the combinations, and one of the things we would want to look at is trying to mitigate them. The day boundaries, if they're removed, you can just compare these two plots here and see then on the top plot that they're rather noticeable, and if they are taken out, then the time series for the clocks looks quite a bit smoother over whatever period of time we're looking at. Of course, if you only care about the clock at a particular epoch or epoch by epoch, then those aren't as important. If you are interested in the continuity of the clock over a day, then understanding what those values is important. They're not hard to estimate, but it could be valuable to have them in a table. So we've been looking at different items or attributes of the clock products that could be valuable to the community in addition to what we are already providing. So some of our other progress work has involved looking at updates to the clock exchange file, which is presently known as clock RINEX, but will become known as clock exchange very soon. One of the things that the working group talked about, a few things that we might find valuable to provide in those files are estimations of the day boundary jumps. And as you've seen on the last page, that could be helpful to users interested in continuous clock series. Calibration data could also be valuable for people who are interested in knowing a calibration of the clock solution is seen in file against some of the reference for certain ground stations, for example. And then there are estimates of frequencies that are also done. These are not observations or measurements, but rather estimates based on those. But they are available and could be included in those files. There is space for them allocated. They just haven't been used since the file's been adopted some 20 so years ago. So these are some updates we're looking at. And of course, any kind of update or fix to the day boundaries have to be done in conjunction with Wuhan and PPPAR, since they had done the work on the combinations. And it's important that we maintain clock differences from that solution. The plot you had seen on this previous slide is not something we could publish on the bottom because it does change the nature of those differences, and it would not be consistent there with the solution that was produced. We had also done some work earlier this year in our working group in providing a statement on the leap seconds and ensuring that the IGS had some kind of a position, given that some of the work that's been going on in that. There's been a number of hot topics going on at the BIPM for timing, and one of them was the role of the leap second in UTC. The IGS, with the approval of the governing board, adopted a position that we have largely developed in this working group, which favors no additional discontinuities in the difference between UTC and GNSS-T, i.e. no further leap seconds if possible. And it was largely due to 4 main points. Effectively, that we have to deal, we would like to have these differences in the implementation of the leap seconds in each GNSS, so that it puts confusion into the system every time we have to deal with them. We have to keep updating them in our records and file formats. The time tags between the IGS time, which is against GNSS time, specifically they're tagged against GPS Galileo and QZSS time. But those change over time if there's more leap seconds, so that's not desirable. And perhaps the biggest issue from an infrastructure perspective is that some hardware can have malfunctions as a result of leap second insertions. One announcement I wanted to make is that just this past month, the General Conference on Weights and Measures, CGPM, had agreed to a decision that the maximum value of UT1 minus UTC will be larger, or a decision should be made on that before 2035. And there was direction that it should be some meetings with some organizations involving, of course, the ITU and others who might be affected by this to determine what that value might be. It's not clear to me where this is necessarily going to head or land, but the idea seems to be mobilizing that there will be an increase in the tolerance of UT1 minus UTC, so that it may not be a leap second, but it could be a leap minute or a leap hour, or something that will push discontinuities to a larger time span, perhaps of something that would take a century or so before anything such had to be inserted into UTC. So if leap seconds are something that are of concern to you or get in your way, it's worth maybe taking a look at, just to be aware of some of the developments that are taking place now. So our future work, our near-term goals are to finalize the timescale computations. And this is mostly to make sure we can get everything finalized in Repro 3, so that whenever the ACC is ready to move those towards operations, we'll be ready to go with a reference frame. Reference time, I should say. We also would we have in mind to work on mitigating the clock date boundary jumps if possible. As you can see, I've done some evaluations there, but we have to do some work in conjunction with PPPAR to see if we can if they can be mitigated or reduced in any way. On a more long-term goal is to look at what the possibility of having several clock files depending on the signal frequency combination. There's been discussion about the fact that we might have slightly different solutions on that, but we have more discussion to do on that between bias and calibration and PPPAR as well. So all of our goals really right now, we're looking at trying to get the combinations from multi-GNSS out, which is really, I think, speaks to the multi-GNSS efforts that the IGS has right now. And that is all I have. So I'll take questions if anybody has any.
Thanks so much, Michael. Questions in the room?
Online?
So obviously everything was crystal clear. So thanks again, Michael. And let's move to the next presentation on ionosphere.
Welcome everyone once again. My name is Andrzej Krankowski. I'm from University of Warmia and Mazury in Olsztyn from Poland, and I am Ionosphere Working Group Chair. Oh, what happened? This how to move? Okay. Related to my presentation, at the beginning I would like to talk something about Iono working group, and in the main part I will present the last achievements from Iono working group, especially real-time Iono service extension, rotifluctuation maps to low latitudes and South Pole, and in the end I will present nice collaboration with two organizations, International Lofer Telescope and especially with COSPAR URSI International Reference Ionosphere Group. 1 month ago in Iono working group we had election, and we include 4 new members. From Italy, Claudio Casseroni, from GPL, Leo Martir and Vargas Panagiotis, and from University of Birmingham, previously from University of New Brunswick, David Temis. For better communication with ESA, I would like also invite Tim Springer to be official also member of Iono working group. Currently, we have about 40 very active members in Iono working group. Related to history, in next year we will celebrate 25 years of IGS Ionosphere collaboration. This group was established in June 1998. I think we will something to organize, and I will be in contact with all members, and in next year we will organize special meeting related to this event. As you know, in Iono working group, currently we have 8 associate analysis center from ESA, from UPC, from Code, NRCAN, 2 center from China, from Chinese Academy of Science, Wuhan University, and also 1 center from Munich, from Technical University of Munich. I am also in contact with next center, also from China, from Shanghai Astronomical Observatory, and in next month, at the beginning of January, we will start to validate and compare also results from this center, and maybe during next IGS workshop will show comparison, and after maybe we will include next associate analysis center in Iono working group. And for example, you can see as example final products, rapid products. Also in 2015 we include new products, rotifluctuation maps, but only for northern hemisphere. And for example, you can see animation from these products for one event, and you can see ionospheric irregularities, this extension computed from IGS network. Of course, all details you can see related also to this methodology. You can see in a few papers. One of them was published in 2018 in GPS solution. Related to the last recommendation, we agree to continue works on IGS Ionosphere real-time service for global ionospheric maps, and also we agree to prepare extension towards low latitudes and southern hemisphere related to IGS ROTI products, continuation cooperation with in IRI and international LOFAR telescope communities. And I would like also to thanks for very, very good cooperation related to real-time Iono products with real-time working group of IGS. Related to the real-time Iono products, we published the first results in 2 publications, one of them in 2020, second in 2021. In there's a publication. You can see everything related to validation and comparison. We establish also permanent service, and you can see data flow from real-time data by IGS real-time centers. Currently, we have 4 centers in this topic. We create combination by 2 centers, and IRI currently IGS real-time products is available for users. And for example, you can see there's 4 centers. Thanks a lot for Wuhan University, Chinese Academy of Science, of course UPC from Barcelona, and CNES from France. I think in very close future also next center from GPL also will be included in next year in this topic. And related to IGS ROTI maps extension towards southern hemisphere and low latitudes, currently we establish service. We use more 3,000 permanent station in this topic. You can see maps and also some exams in geographic coordinates for St. Patrick's Storm from 2015. Related to methodology and validation and comparison, you can see also in this part the last publication published by Yuri Czerniak in Sensors MDPI journal. And for example, you can see over irregularities over southern pole for this event, and also animation for low latitudes above equator. Everything also results are published in mentioned before publication in Sensor. Of course, we prepare very similar to previous format, very similar to Yonex. This new format consists of 3 sections: 1 section for northern hemisphere, second for low latitudes, and the last for south pole. Also, this format is described in this publication. I think we will start to upload especially for users for checking validation in next year this new extension also to CCIDs. Of course, we change a little name. Will be previous official products, and for validation and comparison new product, and of course after agreement during governing board, maybe in 1 year, this new version of ROTI fluctuation maps will be official products from IGS. Related to new infrastructure in Europe, and for example, you can see low frequency area above Europe. Currently, International LOFAR telescope consists of 52 stations. More of them is located in Netherlands, 6 stations in Germany, 3 in Poland, 1 in Sweden, Latvia, Great Britain, Ireland, France. Also, in 2 years, will be established station in Italy, close to Bologna, to Medicina, and in Bulgaria, in Rożen Observatory. And for example, you can see typical international station. For example, it is my station located near Olsztyn in Bałdy. Typical station consists of 2 fields, one related to low frequency, from a frequency band from 10 up to 80 megahertz, and second for high frequency band from 110, 20 up to 240 megahertz. And in LOFAR we have key science products, most of them related to radio astronomy, but also we have a very active sun and space weather project. And for example, you can see the first results related to scintillation from Cygnus A above my Baldy station. And currently we publish methodology in astronomical journal supplements, and related to S4 index, we will publish maybe in 1 month next paper in journal on space weather and space climate. We validate the measurement using also IGS ROTI fluctuation maps. And we also include to IRI group, especially to real-time Gambit software, also IGS rapid products related to global ionospheric maps, and also the first results related to real-time stream. And I think it is also very good tools to promote IGS products in geophysical community. And some two announcement. I was invited by United Nations together with International Committee of Global Navigation Satellite System to attend in two events. One of them 1 month ago was in Baku, second a few days in Vienna, and also during this event I promote especially development of IGS real-time Iono products, roti fluctuation maps. And in the end, I would like to congratulate GPL groups, especially usage real-time maps in to monitor real-time natural disaster. And congratulations, Leo and Attila, related to this work. And I think that you can very fast also to participate in real-time combination from GPL side. Thanks a lot for all of you. If you have any question, comments, please.
Andrzej, I'm afraid we don't have time for questions. I'm sorry, but please don't hesitate to send an email to Andrzej if needed. So to all the speakers, please try to stay in your 10-minute slot.
Sorry.
Presentation. No problem, Andrzej. Let's move to Multi-GNSS and MGEX with Oliver.
My name is Oliver Montenbruck. I'm heading the Multi-GNSS working group of the IGS since about 10 years now. The main purpose of the Multi-GNSS working group, as the name implies, is to conduct the Multi-GNSS pilot project of the IGS and also, say, to promote Multi-GNSS activities throughout all IGS entities. Some overview of news in the multi-GNSS world from the last year. We did not have too many and no fundamental changes, but worthwhile to mention is probably the decommissioning of the first QZS-1 satellite that took place last year. In replacement of that, QZS-1R was set healthy and operational. In the Galileo world, 2 more satellites were set healthy, but had been transmitting already in the last year. Unfortunately, due to the Russian-Ukrainian war, launches for new Galileo satellites could not take place and are postponed maybe to next year. So the constellation did not grow as originally planned. There have been 2 GLONASS K1b launches last year to populate the decaying GLONASS constellation. And in interesting news, GPS-3 antenna patterns have been released by the manufacturer of those satellites, Lockheed Martin, in agreement with the GPS Directorate. For Galileo, the ICD of the Galileo High Accuracy Service has been released, the first global real-time corrections transmitted by a global navigation satellite system. I think that's a quite exciting addition to the portfolio of this constellation. And as I said, initial transmissions have taken place. On the downside, GLONASS was excluded from ILRS tracking, so we can no longer use satellite laser ranging for performance validation of GLONASS since the start of the Russian-Ukrainian war. So politics has entered the GNSS world here. Within our working group and within the IGS, there have been a couple of accomplishments over the last year that I would like to briefly report on. The set of multi-GNSS stations within the IGS network has roughly stayed at the same level that was already reported last year, but we do have an improvement in the quality of the multi-GNSS capable stations. Among others, Beidou 3 signals are receiving better support. More and more receivers are also tracking the new modernized B1C and B2A signals. On the downside, we still have no or essentially no IRNSS S-band support, which is mainly due to the fact that very, very few GNSS antennas would support S-band, and it will always be a hard decision to replace an existing legacy L-band only antenna with an L-band plus S-band antenna. So I don't see a good perspective for that in the future as well. RINEX 4, which was released in December last year, roughly 1 year ago, has found its way into the routine products or data collections. Among others, we are generating a cumulative broadcast ephemeris products covering all types of navigation messages, not only the legacy, but also the modernized navigation messages on a routinely basis, so users can get access to all the information that is really transmitted by the GNSS satellites now. In addition, various receiver manufacturers have offered support for native RINEX 4 observation and navigation files, and a few selected receivers are already providing that inside the IGS network and data holdings. Arturo already mentioned the introduction of IGS 28 of the IGS 20 Antex model, which is a true multi-GNSS antenna model. We had a close interaction with the antenna working group on that. Among others, additional multiband receiver antenna calibrations were added, and we now have satellite-specific calibrations for GPS3 and Beidou 3 satellites. The Multi-GNSS working group hosts a couple of analysis centers or collects their work. Right now, we have a total of 7 analysis centers that provide pretty full-featured multi-GNSS products for typically 5 GNSSs. That is the 4 global constellations plus QZSS. In addition, the portfolio of these analysis centers has increased. More and more analysis centers are now providing also Earth rotation parameters to round off their orbit and clock products. And we have a new product, basically hourly near real-time products from Wuhan University that is a super ultra rapid type of orbit, not updated every 6 hours, but every 1 hour, and is, I think, a useful source for everybody working in near real-time and real-time GNSS data processing. Within the multi-GNSS working group and their analysis centers, the IGS 20 transition is in progress. It is not completed yet, but it will hopefully soon be implemented. Also, various analysis centers contribute multi-GNSS bias products, including differential code bias products, but also observation-specific biases, including phase biases for integer ambiguity resolution. Continuous monitoring of those products takes place from the MGEX website, and the working group also continues to maintain the GNSS satellite metadata file. Some other studies that have been conducted, there has been a paper publication on the performance assessment of MGEX Beidou 3 orbit and clock products within this year. There has been a study of group delays for Beidou, comparison of broadcast and IGS-derived group delays as part of the multi-GNSS working group. We have assessed the manufacturer calibrations of Beidou 3 phase center offsets and have checked whether they can contribute to the reference frame scale in the future. And there has been a study of how phase center offsets affect the reference scale for different GNSSs. An ongoing project, unfortunately ongoing since literally one year, is the preparation for ILRS tracking of all Beidou MEO satellites. This is still in the process in the making to cross-connect the Chinese Satellite Navigation Office and the ILRS so that they mutually agree on what can be done here. Considering the recommendations from the IGS workshop that took place in the summer, there were 4 key recommendations. The first one is basically a resumed recommendation from earlier workshops, namely to relocate all MGEX products to the standard IGS data or product repository. This is now planned for late January. The data centers first want to say finish any work related to new file naming conventions and the IGS 20 transition, but it is now say promised to take place by the end of January. Users will be informed by IGS mail when that takes place. And as a first step, all data starting from January 2022 will be moved from the MGEX campaign directory into the regular product directories. Then there was an action item to request governing board approval for the satellite metadata SINEX file format. Unfortunately, we had no other governing board meeting right after the workshop, so that will now take place today or tonight in today's governing board meeting. Then an action item was to establish a task force to define and implement a toolchain for multi-GNSS orbit clock bias combination and to establish an operational product. This task force has formed from, say, entities around the IGS. It was an open call for participation. It is not, say, a specific multi-GNSS working group activity, but has invited many external participants. This group has formed itself in September 2022, and the work is currently in progress. Particularly, we have already defined a kind of general set of requirements for the orbit combination and are now looking into the way forward for software implementations. Finally, there was a recommendation to study options for supporting GPS L1 and L5 user community through dedicated IGS clock or bias products. In that case, there has, to be admitted, no activity so far. The combination task force that I have just mentioned, since I'm also chairing that, and since we do not have a dedicated slot here in the AM meeting for the combination task force, let me briefly review what it has been doing. Basically, its scope is to coordinate and advance existing efforts for product combination across the IGS so that we end up really with a multi-GNSS combined product. The call for participation was issued right after the virtual workshop in July 22, and we've formed that group of about 15 members from 7 institutions in September 22. Key accomplishments were that, first of all, the group agreed on a focus on a combination for multi-GNSS PPP users, which has, say, slightly different conditions than a combination that would, for example, be favoring reference framework. So that is a decision to be taken and to focus on that aspect. The overall roadmap would be to have to start with an orbit combination, then add clock and bias combination, and to drop, however, SINEX combination, which is important for reference frame users in the first instance, and address that only in a later stage. We have done dedicated studies on the question of orbit interpolation to deal with different step sizes of current product, and we have formulated specific requirements for how an orbit combination should look like to meet the user needs. And as a next step, there is a plan to build up a Python software repository for orbit combination, but that will then start actually next year. That's it from my side. If you have any questions, I'm happy to answer them, or you can always reach me by email at the given address here. Thank you very much.
Thanks so much, Oliver. Questions in the room? Yes, please.
Tom Herring here, Oliver. I'm just curious, how appropriate is the E5 calibration for Galileo for L5 for GPS?
Which calibration do you mean?
The E5 calibration from Galileo, the frequency is very close to the GPS L5, right? So presumably that would be a usable calibration to use?
So the you mean receiver antenna calibrations?
Yes, yes.
Okay. It was not clear to me whether you refer to satellite combinations, satellite antenna offsets. To my understanding, it is very close if you talk about the E5A. E5B is a neighboring band, and E5, the combination of E5A and E5B is again a little bit offset. I think E5 might benefit from independent calibrations, and to my understanding, out of the Geo++ combinations, they do offer separate combinations for E5A and E5B and E5.
Thank you.
No questions online? No? Okay, so thanks again, Oliver, and let's move to the next presentation on PPP with ambiguity resolution from Jianghui GENG, and this is a pre-recorded presentation, I think.
Yes. No, he's
oh, you're online.
Yeah, I'm online, but I'm not have a stable connection, so it better play the video for me, and I can answer your questions.
Oh, great, thanks, Jianghui. So we're gonna show your presentation from here.
This is the progress report for the PPAR working group. I'm Jianghui again from Wuhan University, the chair of this working group. The major responsibility of this working group is to coordinate the phase-bias generation within the IGS analysis centers to facilitate ambiguity resolution at a single station. The main goals are to investigate the interoperability of the phase-bias products from contributing ACs and to analyze the combination process considering the consistency of the cellular clock and bias products. Finally, to initiate a pilot clock bias combination project to cross-validate the quality of individual AC solutions. In the IGS 2022 virtual workshop, the PPAR working group proposed a few recommendations to target the main goals above. At first, ACs were encouraged to produce phase-bias products and attitude cotillions. Second, antenna phase center corrections should be applied by all ACs to geometry-free biases, including differential code biases and Melbourne-Ubler combinations. Third, a pilot combination project should be started to help ACs improving their phase bias products. Finally, some other relevant issues such as group delay variations on BDS code biases, the boundary discontinuities of integer clocks, as well as BDS, QZSS phase bias products. This is a summary table showing the MGEX products, providing attitude cotillions. We now have 4 ACs providing phase bias products for GPS and Galileo satellites, and 2 for BDS2 and BDS3 satellites. The cotillion products have a sampling rate of 30 seconds, which is the same as that of the satellite clocks. Concerning the question of how many decimal digits should be reserved for attitude cotillions, we tried 10 globally distributed stations to compute antenna PCO corrections in the inertial frame for all GPS, GLONASS, Galileo, and BDS satellites. The current GNSS cotillions have 16 decimal digits by default. We compared the PCO corrections between those computed based on 16 and 6 digits. We can find that the BDS and GLONASS satellite PCO corrections are more affected by reducing the decimal digits from 16 to 6. The maximum PCO differences reach as minimal as 100th millimeters. In this table, we computed the PCO corrections for the cotillion decimal digits reduced from 16 to 3, 5, 6, and 7. It can be seen that if there are only 5 or fewer decimal digits, the impact could reach a significant level. 6 or 7 decimal digits seem more reasonable, and the size of the quaternion file can be reduced by 1/3. Besides the impact on PCO corrections, we also computed the impact of reducing decimal digits on phase windup corrections and positioning precisions. Fortunately, we found no significant impacts if we reserve 6 or 7 decimal digits instead of 16. On account of the antenna phase sensors applied to geometry-free biases, after a few email circulations, the relevant parties within the IGS have agreed on a new keyword added to bias SANEX format. This keyword would tell which antex file is used for the bias generation. An email was sent to the IGS community last month, and the relevant article by Wuhan and Geoscience Australia has been under review. Since the IGS 2022 workshop, the PVR working group has begun to establish a web page showing the routine combination results of clock bias products from all MGEX ACs. The goal is to cross-validate the phase bias quality of each AC and encourage contributing ACs to improve their products. Now the system is under internal evaluation and would be online early next year. We use the internal combination orbit and reference attitudes generated by the group's software. This is the result for the clock bias consistency among all MGEX ACs for day 268 in 2022. We produced the phase clock combinations for GPS, Galileo, and BDS, but the legacy clock combinations for GLONASS from 6 ACs. You will find that the clock bias consistencies are not uniform across all satellites or all ACs. We will also present visual results for ambiguity fixing rates and PPP validation in future. The future work of the PVAR working group would be finishing the web page. We would begin to study the day boundary discontinuities of satellite phase clocks. A standardization of BDS group delay variation would be necessary, and a consensus is required among the bias, PVAR, and Ionosphere working groups. Through these activities, we are expected to contribute to multi-GNSS technical excellence within the IGS strategic plan. Thank you.
Okay, thanks so much, Jianghui. I would apologize for the technical issues we had to face, but it's okay. Let's take some time for questions, if there's any. From the room? Not from the room. Online, do you have questions?
No questions online.
No questions. So thanks a lot, Jianghui, again. Thanks a lot for
Thank you.
being connected online and for the great job. Yeah. Thanks again.
Okay, thank you.
Real-time service. This is the agenda of the talk. I will give an overview of the real-time working group charter at the beginning for those of you who are new and not familiar with it. Then I will report on our activities at the IGS workshop this summer, and also summarize the progress that we made from that workshop on. And the last point of the presentation will be the appointment of a new real-time working group chair. So one of the main goals of the working group is to maintain and expand the multi-GNSS real-time reference station network of the IGS, and also to monitor and to improve the quality of the real-time observations and the broadcast ephemerides that are transmitted by these stations. Then, of course, we want to provide precise real-time corrections for orbits, clocks, biases, and atmospheric delays, and we want to monitor their quality and also provide combinations of individual data streams and generate the IGS real-time products. Then further Furthermore, we develop new and improved real-time products and work with the Real-Time Analysis Center coordinator to transition these new products into the IGS real-time service. We also develop and improve open standards for real-time data and products, and we investigate new streaming technology. Of course, we also provide access to reference station streams and correction streams through the internet. If you'd like to have more details on our activities and more information on the working group, please visit our new website. The link is provided here at the bottom of the slide. This is the agenda of our real-time working group splinter session at the IGS virtual workshop. We have made a short summary of our activities since the previous workshop, which took place in Wuhan. And then we had 4 very interesting presentations on scientific use cases of real-time products. The first one was on real-time global ionospheric map estimation and was presented by Qi Liu. Then the second one was on real-time tropospheric estimation presented by Tomasz Hadas. The third one was on real-time geohazard early warning, an early warning system by Jingyang Yang from GFZ. And the last presentation was on the ionospheric detection of the earthquake event Tonga, presented by Attila Komjathi. And then in the last action item at the workshop, we made a brainstorming for ideas for a roadmap of future IGS real-time activities. The recommendations that we derived from the workshop were the following 3. We decided to extend the IGS SSR format with new messages for GNSS satellite attitude, as well as the center of mass offsets. And we want to do this within a year. Then we also wanted to define an agreed format and broadcast the RMS map associated to the real-time VTech product. So maybe I should explain this a bit further. About the IGS SSR format, the working group has actually designed and standardized an own format for streaming IGS state space corrections. And this is already used for all the IGS real-time products. And these messages can or will be further extended in the future. There is also a ionospheric correction stream broadcasted in that format. And the new addition to the format will be to develop messages for a quality indicator. This is this RMS map, which will be associated to the real-time VTech product that has already been streamed. The last recommendation was to define a roadmap for future IGS activities based on the feedback from the virtual workshop. And we wanted to do this by the end of the year. So we made a follow-up video conference in November of this year and started the discussion on the roadmap. So we already have these 2 recommendations for roadmap items that are already introduced. And we have identified from the large pool of ideas the following items that we want to further look into. The first one is to further extend the IGS SSR format with new messages for phase center variation and group delay variation corrections. Then we want to also estimate satellite-dependent slant tech corrections and agree on a format for them, and then also broadcast them in this format. We have a slightly larger timeline for this 3 to 5 years. We also want to look into multi-layer real-time vertical tech estimates, as well as using and providing phase biases for the IGS real-time products to enable PPP with ambiguity resolution on the user side. So the last point of this presentation is the appointment of a new real-time working group chair. I will be stepping down from my position as real-time working group chair after 4 years by the end of this year, but I will stay a member of the working group, and I will assist in the transition to the new chair. So there was a call for applications in the last week, and I have received 2 applications from candidates for these positions. So we will have in the future, and this is new, we will have a chair and a vice chair of the working group. And the 2 candidates are Axel Rülke from BKG, as well as Ningbo Wang from CAS. So this Wednesday on December 7, we opened an online voting form with the help of Ashley from the Central Bureau. Many thanks again for the support. This vote will stay open for 2 weeks until December 21st. And depending on the results, we will have a new chair and a new vice chair, depending on who of the candidate gets more votes. I will communicate this result before Christmas, so I'll try to communicate it after the poll closes. So we should have that finished by the end of the year, and then we can start into the new year with a new chair and a new vice chair for the real-time working group. So this is the end of the presentation. Thank you very much. I'm very sorry I cannot be with you in person or live, but if you have questions, then please contact me at my email address, and I will write back as soon as I can. Thank you very much.
Okay, so this was the presentation from André. I guess he's not online, so we cannot ask him questions directly. So again, please don't hesitate to send him an email or if needed. So let's move to the next presentation, which is on reference frame, given by Paul Rebischung. And Paul, are you online?
Yes, I'm here, Felix.
Great, the floor is yours.
Good morning, afternoon, or evening. I'm Paul Rebischung from IGN France, coordinator of the reference frame working group. And can you see my slides?
Yes.
Thank you. So let's start the presentation by reminding the main objectives of the working group. First, we generate a series of operational products. We combine the daily SINEX solutions provided by the different IGS analysis centers to form the IGS daily combined SINEX solutions, which include daily station positions and Earth rotation parameters. And every week, we also update a long-term stacking of the IGS daily combined SINEX solutions to form the so-called IGS cumulative solution, which includes long-term station positions and velocities. Another objective of the working group is to specify the successive reference frame used to align the IGS products based on the successive releases of the ITRF. So I've listed here the few latest: IGS 14, which was the IGS realization of ITRF 2014, then IGB 14, which was an update on IGS 14, then IGS R3, the reference frame that was used to align the IGS Repro 3 products, and which has the peculiarity that its scale is not aligned to the ITRF, but based on the calibrated phase center offsets of the Galileo satellites. And finally, IGS 20, the IGS realization of ITRF 2020, which was published earlier this year and was just adopted for the alignment of the IGS operational products. The next objective is to collaborate with the IGS antenna working group in updating estimates of the GNSS satellite phase center offsets. So usually, every time a new ITRF is adopted, we re-estimate satellite phase center offsets based on the scale of that new ITRF and include the re-estimated PCOs in the new IGS antex file. And finally, the last main objective of the working group is to provide the official IGS contributions to the successive ITRF updates. And this is achieved by combining the daily SINEX solutions provided by the IGS ACs as part of the successive IGS reprocessing campaigns. And for instance, the daily combined Repro 3 SINEX solutions form the IGS contribution to ITRF 2020. Now, what's new since the IGS workshop in June? Well, one of the workshop recommendations was to finalize and publish the IGS 20 reference frame and the corresponding antex file, and we made it 4 days late in July. Another recommendation was to actually switch to this IGS 20 framework after a 2-month trial period that would allow ACs and users to prepare for the switch. And the trial period started on time, but it was later decided to extend it until the end of November in order to allow additional time to prepare for the switch. And finally, the switch of the IGS products to the IGS 20 framework happened on November 27, smoothly as far as I can tell, but I don't know actually how many complaints or distress calls were received by Salim or others. And another new item since the workshop is the publication of a first release of the new version of the IGS cumulative solution, compliant with the IGS 20 framework and the Repro 3 standards. But this first version is so far only based on the currently available Repro 3 product series that is on data from 1994 to the end of 2020. And as announced in IGS Mail 8284, the weekly updates of the IGS cumulative solutions are now temporarily suspended until the Repro 3 product series is extended up to the date of the switch. So that's our future work in the short term. We expect AC contributions to this backfilling of the Repro 3 product series by the end of January. The daily combined RINEX solutions will follow shortly. And so updates of the IGS cumulative solutions are expected to resume sometime in February, based on a complete up-to-date series of RINEX solutions compliant with IGS 20 and the Repro 3 standards. And by the way, I would like to take the opportunity of this halt of the IGS cumulative solution to maybe revise its update rate. The thing is that every single weekly update is of little added value to such a long-term solution. So it seems to me that less frequent updates than weekly should fit most usages of the IGS cumulative solution. And besides, less frequent updates would also allow us to improve our analysis of the station position time series, and in particular offset detection, hence improve the overall quality of the cumulative solution. So I would like to ask the following questions to users of the IGS cumulative solution. Are there usages which really require weekly updates? Otherwise, which update rate would you be satisfied with? Every month, every 2 months? So thanks in advance for any feedback. And then on the longer term, well, I just pasted here other recommendations that were made at the workshop in June and which pinpoint potential areas of improvement for the IGS terrestrial frame products. First, understand why the station position estimates from TU GRATS are clearly more precise or appear more precise in the combinations than those from any other AC. This is still quite a mystery at the moment, but if that mystery is solved, this could obviously help other ACs to also improve their station position estimates and eventually benefit the IGS combined station positions. Then aim at further reducing the spurious periodic signals in the IGS station position time series by further advances in orbit and tide modeling. Third, investigate the terrestrial scale and scale rate differences between GNSS, that is based on the calibrated GNSS satellite PCOs, and the other space geodetic techniques. And finally, aim at mitigating the impact of offsets on the long-term stability of the ITRF by investigating in situ antenna calibrations, considering next generation of station installations less subject to environmental errors, and keeping equipment changes at reference frame stations limited to a minimum. So all these recommendations are clearly beyond the scope of the reference frame working group only. They are more like incentives to the whole IGS community to try to improve our collective contribution to the ITRF. So any contribution by anybody on any of these points is welcome. And also note that there's no deadline attached to any of these recommendations, although obviously it would be nice to see some progress made before the next reprocessing in ITRF. And that's all I have. Thank you. And I welcome any questions.
Yeah, questions to Paul? Yeah.
Yeah, hi, Paul. This is Richard Gross. So if you want to increase the latency of the cumulative solution, does that include the EOPs?
No, no, the EOPs are produced weekly. The final EOPs are produced weekly. And they come from the combination of the daily AC solutions. So from the daily combined IGS solutions, and the update of the final EOPs will remain weekly.
Okay, all right, thank you.
Please, Tom.
This is Tom Herring, Paul. I'm just curious, have you looked at the ratio of the vertical uncertainty to the horizontal uncertainty in the TU grass solution? It strikes me when we looked at that, that seems to be a smaller ratio than you see for anybody else. And the only way you seem to be able to do that is somehow by having atmospheric parameters not to be partially constrained or something like that. I'm just curious if you've looked at that.
You made that remark before, Tom. And then I looked at the ratio that I see between the horizontal and vertical formal errors in the TU Graz solutions, but I don't see such a difference between the ratio in the TU Graz solution and those from the other ACs. So
yeah, maybe I will send you some results.
Okay, let's talk about that more.
Questions or comments? Online, something?
Nothing online.
Okay, so thanks again, Paul. And let's move to the next presentation, which is on RINEX, given by Ignacio, and it's an online presentation.
Hello to everybody. Sorry we could not be there in person. It would be really nice to meet you all again. So let me just go through the RINEX working group as a general discussion. So the IGS RTCM RINEX working group is a co-sponsored working group between the IGS and the RTCM subcommittee 104. It serves both communities at once to satisfy different requirements together and preclude confusion and to help move things forward faster. So half of the members are from the IGS. We have about 60 members. If anybody wants to join, associate members, please let me know. The chair is one of the RTCM subcommittee 104 representatives. So I attend the 104 meetings as far as possible. The changes in RINEX format are agreed at RTCM level, which involves most of the manufacturers of equipment that we end up buying for our stations, and also at the IGS level, which of course covers most high-end users of GNSS data. And this helps in the adoption and in keeping the format fit for purpose as the constellations evolve and new requirements come up. RINEX 4 was the main issue this year. Obviously, it was introduced. It was accepted the last governing board meeting last December, so 1 year ago. The observation files are backwards compatible to RINEX 3. The navigation files are not backwards compatible. I think I've presented this in every forum that I was invited to make sure that people understand the differences. Meteor files are backwards compatible. IGS merged navigation files will remain as they are. So the old name RINEX 211 file, BRDC, the long name BRDC00 IGS in RINEX 3, and the new BRD4 00 DLR is the current example of a RINEX 4 full navigation file. The validation and trial use of RINEX 4 files has proceeded this year with the help of the IGS Infrastructure Committee. They organized a campaign, which is contained in this directory shown here in the second bullet point. DLR produced the example mixed navigation file, and early users can access station data and navigation files from May onwards. So thank you very much to Markus, Bradke, and the IC for all that. There are about, like I say, there are a few dozen stations, and they have been generated for the use of testing software and seeing how things go. For 2023, looking forward, we have planned RINEX 401. This will be a minor revision, but of course, with a new standard and rewriting the entire format document from 3 to 4, There's, of course, typos got in there, so some more clarifications are needed, and those will be done. I want to expand also some comments and explanations as far as possible. And also I've been requested to add an R signal code for GPS, which will increase the table 2 of GPS signal. This is for something that's coming in a few years. Nothing to worry about yet, but we want to reserve this signal code for a signal that's upcoming to future GPS 3 satellites. In any other business we've covered, we had a teleconf in November. There's some issues that are open and continue to be open because we have to evaluate the effort and the actual need and the user base. Recurring regularly is the navigation bit stream, whether we should store the actual bit streams from the satellites. This is a lot of data, and there's no agreed format. There's an agreed format between people running occultation missions, radio occultation missions, but this format is not agreed for other users. So anyway, that's where we are. There's an espace correction format that was agreed a long time ago by UNAFCO and some others, and then it's been extended informally at CNES. So this is a point that continues to be open. And also it was brought to my attention this future LEO PNT, to keep an eye on it to see if it could affect GNSS data formats and standards in case such data would ever be recorded at our stations. We know that it is not a secret that, of course, we have LEO PNTs or LEO satellites planned for Beidou. They have just been approved for Galileo as well, at least as a research and development effort for now. But there's also some private ventures going around and constellations of LEO satellites which will offer, or at least they claim that they will offer, PNT solutions for users. And there's already at least one manufacturer that has reached agreement to try to track such fast-flying satellites overhead. So if this impacts GNSS data, we want to be ready in the RINEX working group to make sure that we're responsive. So that's all I have for now. Sorry for not using the template that everybody else used, but at least it woke you up. And thank you very much for your attention. If there's any questions.
Thanks to you, Nacho. We have time for questions. I don't see any in the room. We have
none online.
So if not, thanks again, Nacho. And let's move to tight gauges. And this is a pre-recorded presentation from Tilo.
Yeah, dear colleagues, dear members of the IGS governing board, dear associate member, I apologize that I'm not being able to be with you today, neither in person nor online. So I have to give my report in a pre-recorded form. It's about the tight gauge benchmark monitoring working group, and I have used also, and I would like to acknowledge the work of the members of the Tiger working group. What is about tight gauge benchmark monitoring? It's quite important because the sea level is globally rising, but we have not only that we have radar altimetry for measuring the sea level, but we have tight gauges, which constitutes a very long history of measurements, more than 100 years, in some areas even longer. It's an example. In 2012, my group installed a tight gauge in Semarang in Indonesia. I use this example quite often, and due to the subsidence, the local subsidence of 10 centimeters per year, the tight gauge is sinking, and that means that the sea level recording we are taking is rising and rising. In 2018, also the area around the tight gauge was elevated, and in 2022, in June or July, this tight gauge had to be removed because the sea level in high tide situations became so high that the electronic box was subject to flooding in these situations. And our colleagues and partners in Indonesia from BIG installed a new tight gauge hut on top of the old tight gauge hut, so we have an elevation of 2.5 meters now. And they also installed pillar for the GNSS antenna, and we hopefully will in February install the GBS, GNSS, and tight. The need of GNSS at tight gauges can also seen from the lower right panel. It's a tight gauge record from Manila, which is now more than 100 years in data length. And in the first 6 years, starting from 1900, we had a very moderate sea level rise. But later on, the population density increased in the Manila area, and also the water usage from groundwater, and therefore the subsidence started. And only if we are correcting the vertical motion of the tight gauge with GNSS, we can correct the sea level record so that we can get the values equal to the one we have in the from the radar altimetry. The aim of the Tiger benchmark working group or the Tiger working group is that we are working with the UNESCO CLOS community. This CLOS community is operating the long-term tight gauges for sea level research, for global climate research, and the IGS is supposed to provides the reference frame for the tight gauge measurements and the corrections. The Tiger working group is also doing the maintenance of the global virtual GNSS at tight gauge network. So it means we don't have any own GNSS or tight gauge in our group. Of course, group members have them, but it's not as a group. And one of the aims is also that we are establishing the local ties between the GNSS antenna reference point and the tight gauge benchmark in order to bring both quantities together, and also providing metadata and so on. And the main purpose is also that we are computing the precise coordinates and velocities for the GNSS stations which are on top of the tight gauge or in the vicinity of the tight gauge with a significant delay. That means we are working within the REPRO campaigns. And we are also providing training to the tight gauge operators through workshops, and also we are giving advice to the to the CLOS station operators how to install a tight gauge or a GNSS at tight gauge. The major accomplishment over the last years, the University of La Rochelle group and GFZ Potsdam processed a large network of GNSS at tight gauge stations. GFZ did it for Benjamin Medal in the IGS Repro as analysis center, but also additionally with the stations from the Tiger network. The resulting time series already the products, RINEX products are available through a DOI number, so they can be downloaded at any time in a long time repository for both time series. The La Rochelle and also Solone data center is also very important for the Tiger working group. They are acting as the data center, so they are collecting all the RINEX data, also leveling data and information about tight gauges, and they are also hosting the network coordinator for us. They are collecting and distributing the leveling ties between the antenna reference point and the tight gauge benchmark monitoring, tight gauge benchmark. And they are providing also this excellent service for the CLOS and Tiger community. And also the network coordinator provides service to keep the Tiger network up to date and growing. A few more words to the Zonel data center hosted at the University of La Rochelle. Over the past year, they have done a lot of work for integrating new leveling data between the antenna reference points and the tight gauge benchmarks, or tight gauge 0, which is the quantity we are needing in order to connect both quantities, the sea level and the GNSS data. And also they did a lot of effort in integrating or collecting the RINEX read files from the tight gauge stations, and also some other works to assist the station operators and the users. They developed some tools for that. On the other hand, Corona affected our work because we are missing important outreach activities in the past years. We are missing also the input for new stations because mainly the information about new stations are coming through our meetings with the community. Recently, there was a CLOS GA18 meeting in Paris. Möppelmann attended, and so we all now have some progress in this matter as well, or again. There is a Chinese company, it's a semi-commercial scientific company. They are going to install 5 new GNSS tight gauges, and they will also make it available for the community. And we are in discussions where to place it and how they can be integrated. The number of stations collected at the Sonel data center, that's not only the Tiger station, but also other GNSS tight gauge station, increased over the past years. In 2021, we had 1,229 stations, and now we have more than 1,250 stations at the end of the year. What we see as the IGS networks is also that we have a decline in the number of stations measuring. So it's not only it's not a stabilization, but it's really going down the amount of stations which are contributing to that. And this is a point we certainly need to discuss how to overcome this problem. The leveling data, I mentioned it before, which are collected at the Sonel data center, is also increasing number of tight gauge sites with leveling ties. So we increased the number over the past year from 209 ties to 250 ties. And this is a very nice and good development because it helps us a lot to provide the correct service to the users. We are recognized by the CLOS, by the UNESCO CLOS group as a working group, and therefore some words to the interaction with them. We have 200 CLOS stations where we have co-located or nearby GNSS stations. These are roughly 86% of the total number of stations there. And only for the moment, we have 113 active GNSS stations with a decline in the number, where it's also the point where we need to work. We have also some stations where we don't have any GNSS in the vicinity, but this is also a point which needs to be discussed with the CLOS community during the next meetings. I mentioned in the beginning that we had 2 groups providing a solution to the Repro3 campaign. So it was the Sonel working, or the La Rochelle working group, which provides a very large set of stations, more than 600 to the Repro3, and GFZ, also Benjamin Mennel, processed quite a number of stations for the Tiger stations, but also for the GNSS tight gauge stations. And I mentioned these data is available through the DUI numbers I have in my overheads before. The Sonel data center is also very convenient to get the vertical land motion values from these solutions displayed. It's not only here the GFZ and La Rochelle solution, but there are more solutions, and it's very nice and convenient for the user to go here and have a look on the individual rates. And you can also have, with one click, you can also get the time series displayed, and you can download it from here. In June, we had this IGS meeting, and there is highlights from the discussions. So the understanding of sea level change and coastal hazards requires a stable reference frame, which is provided by the IGS for the tight gauges. And we had also a lot of discussions about the capabilities at the Sonel data center, which is really highly appreciated by the community, because this lets you download and also display the solutions from different analysis center, which is very convenient if you are looking for the differences between the solution and looking for the effects, which could be a reason for that. What we also discussed that we need to provide better service to the non-IGS users and non-GNSS experts, because if you compare solutions, of course you will get differences, but also the problem is that the non-GNSS experts and non-IGS users have hardly an understanding of what equipment changes can have an effect on the solutions, that it needs some better outreach from our side to this community. We had some emerging ideas from the meeting. So we need to better work with the close group of experts to get the feedback on the quality of service we are providing, to define more stations which should be equipped with GNSS receivers, and to better connect with the tight gauge community. But also there was some discussion. Gary Mitchum, who was part of the working group, is also the president for the IAPSO Commission on Mean Sea Level and Tides, and there are some efforts or some discussions about the interconnection between both communities, this commission and the IGS and Tiger working group, or the experts here. What is still pending is the how-to guide for the IHO tides, water level and currents working group. There was an action item on one of the past Class GE meetings. This is still an open point which has not made any progress. And also we discussed that we need guidelines how to label Tiger stations in the IGS community. And they had also these recommendations we made that the non-experts community needs guidelines for understanding the jumps, drift, and non-concurrent GNSS time series from the individual solutions. This is really an open point, and we are asked again and again why the different solutions are giving different results, even when using the same database. That's the end of my presentation. Thank you very much. And again, I apologize for not being able to be with you today. And I wish you a good meeting and also later on a good governing board meeting. Thank you very much.
Okay, so please don't hesitate to send questions to Tilo if needed. And let's move to the Tilo.
Tilo's not here.
I know Tilo is not online, but I have a question maybe Benjamin can answer. For those who are online, this is Zuhair Al-Tamimi speaking from IGN France. To my understanding, there are two solutions, one from GFZ and one from the University of La Rochelle. And to my understanding, there is no combination or intercomparisons of these two solutions. Is there any plan to resume that activity, which is supposed to be part of the objective of the working TIGA?
Okay, it's Benjamin Mendel. As I think it was mentioned by Tilo, it was discussed during the workshop in June, but actually there was no activity until now. But
there is no plan in the future for that?
This question goes to Tilo. But it would be important. And we discussed during the workshop, especially one station where it was very obvious that we received different results due to different strategies for the time series assessment or adjustment analysis. But yeah, the question goes then to Tilo.
I would also have a question to Tilo. He was talking about the users. Do you have any idea who are the users, and do you have any statistics about number of downloads or so?
Again, I think I have to forward this, or we have to forward this to Tilo.
Okay, thanks anyway for your comments and questions. And let's move to the infrastructure committee presentation, and this is given by Markus.
I'm Markus Bradke from GFZ in Potsdam, and I'm the coordinator of the infrastructure committee since 2 years now. Next slide, please. So a quick overview of our working group or committee. So we're basically a forum of professionals that includes network and station operators, as well as data centers and GNSS IT professionals. And we also have members or ex-officio members, that they are chairs or coordinators from other IGS working groups. So we develop policies, standards, guidelines, and recommendations, and we maintain and improve the GNSS data and information systems upon which the IGS product quality and responsiveness relies on. And yeah, we basically ensure the overall effectiveness of the service. Okay. So let's come back to the recommendations that came out of the IGS virtual workshop in June this year. So recommendation 1 was following the input from the community. We develop a roadmap to enhance the IGS tracking network to meet the shifting user needs. Recommendation 2 was that we need to advocate for the importance of information security across the IGS to improve the resilience of the infrastructure and also to increase the trust and the confidence in our data and products. And recommendation 3 was to explore modern standards, data storage and access methodologies to improve the fairness, the IGS data and metadata. So that includes thinking about cloud-based storage formats, accessing data via APIs, and also implementing GeodesyML as the new metadata standard across all networks, not just IGS, but also UREF and RPREF, for example. Recommendation 4 was to develop a proposal to investigate a higher tier of data center, known as Global Archive, which would set mandatory requirements such as quality control, synchronization of data, and some form of several agreement with the IGS. And the last recommendation was that we actively engage with all working groups to support them in accessing the data and products needed to succeed in their objectives. Okay. So the progress since the workshop, I always put the recommendations in brackets so that we have an idea where we are going to. So yeah, the first one was to develop a roadmap for the future of the IGS network. So Ruddick and myself, we are currently working on a network white paper or position paper. And the draft version will be presented later on today. We will revise the current IGS course guidelines from 2015. And yeah, we want to work on capacity building, meaning that we want to implement some kind of wikis and knowledge bases and to further outreach and engage with the community. So for recommendation 3, we worked on GeodesyML. We have a little task team that deals with GeodesyML. So we officially moved the standard from the Geoscience Australia repository to the IGS one. We are working on the next release to improve the fairness of the metadata. So the GeodesyML will include information about data licenses, which networks the station belongs to, also where the data will be sent to which data centers. And we are currently working on 2 independent reference implementations, which are both in validation phase. One is the SLM 2.0 by the Central Bureau, and one implementation is currently in validation at GFZ in Potsdam. Then, a lot of items related to recommendation 5. So, working with other working groups. So we actively collaborated with working groups and data centers for a smooth transition to the IGS 20. We updated the guidelines for long product file names in the IGS. We also worked on the transition to RINEX 4. So the official move is scheduled for early next year. So currently we are having a campaign directory, and we are working on to moving RINEX 4 files into the normal archive structure. And as you heard earlier, also from Oliver, the Multi-GNSS working group on the merge of products to the official product portfolio, which is scheduled also for early next year, probably end of January. Future work, we want to promote the importance of information security. So Pat Michael and I see we have to work on that. We also want to explore modern data storage and access methods beyond RINEX. So we want to work on a feasibility analysis to use TileDB as a storage format, and also to build APIs for custom file generation based on TileDB. And for the global archive plan, that was a recommendation 4. We need to develop a concept, and we need to gather requirements in the next 4 to 6 months. And then it comes to the design phase, also a call for participation. So we need at least data centers to make that plan worthwhile. And if we have that all together, we can work on an implementation and a trial phase. So, okay, there was another slide here, which was basically a wish list from the IC. So we would ask every station operator and data center to actively participate in the infrastructure committee. Your input is very much appreciated, and that's from my side. Thank you very much.
Thanks to you, Markus. Comments, questions?
Yeah.
Yes, please.
So I just want to call out to Markus and Ryan. This working group has a lot going on. You can see what all is happening here, and there's a lot of moving pieces. So I just want to call out them because there's a lot of work that's going on in the background that you don't see, and you necessarily won't see until the product is actually delivered. So.
More comments or questions? Nothing online? Nothing. Okay. Thanks again, Markus.
Welcome.
Let's move to the next point, and we will start talking about working group sustainability with Ryan.
Yes, thanks, Leo. So yeah, again, my apologies for being unable to attend in person. Today, I'm just going to give a brief update on the Committee on Sustainable Working Group Governance. So the committee members are listed on the slide there. I'll just note we've had 2 members move from the committee over the last year. So we are open to new members. If you're interested in being involved, please reach out to myself or one of the other committee members. The committee is based around the idea that without active participation, the IGS as an organisation is not sustainable. This aligns with Goal 3 of the IGS strategic plan, which is to foster a resilient, sustainable and effective organisation to support an expanding and evolving community. The committee was established just over a year ago with the goal to evaluate the current governance arrangements within the working groups, pilot projects and committees, and work on ways to invigorate participation. The focus of the committee over the last year has been on understanding the gaps in the governing policies and engaging with working group and pilot project chairs to understand where additional support is needed. The first deliverable from the committee has been a revised policy for the establishment and governance of working groups and pilot projects. And this draft policy will be presented at the governing board meeting later this afternoon. Key points in that policy are that we've established a process for having a vice chair, improved the policy around the life cycle of the working groups, and clarified the role of the working groups on the governing board. As a result of research undertaken, the committee's also established a series of recommendations that will form our work plan over the next year. These include capturing metrics on participation, developing a better process to update the governing board on the status, risks and issues associated with the working groups, improving administrative processes and engaging with the community to encourage participation. So I guess as part of that outreach or engagement, let me say that if you're currently not actively involved in the IGS community and that you feel you have the capacity or capability to contribute to one of the working groups, pilot projects or committees, then I suggest reaching out to the Central Bureau or the chair of the particular group, because with the support of the community, we can be a strong organisation with a diverse user base that is set up for the long-term sustainability and success. That was a very short update, but I'm open to any questions.
Questions or comments to Ryan?
Not online.
Or online? Okay, so thanks again, Ryan, and I think it's something like 4 in the morning for you, so I appreciate very much your efforts for being with us. Thanks again. Unfortunately, Myra was not able to join us to talk about this new pilot project, but I think that Ashley can say a few words on it.
Yes.
Thank you, Ashley.
Hi, everyone. I'm presenting on behalf of Myra. Not really a full presentation, but she did want to announce that she will be having her first virtual kickoff session for her new pilot project on GNSS for weather and climate resiliency. It will be, the year on this is wrong, but it will be next year, January 18th, around 1 o'clock UTC. And we will be sending out announcements via IGS mail and our social media. So be sure to follow us and subscribe to our mailing list to stay up to date on this. Thank you.
You, Ashley. Right, I think this is it for the working group presentations. On the planning, we have Central Bureau announcements. So Ashley, again, I give you the floor.
Coming soon, we will be having a new associate member portal. Be sure to keep up to date on our IGS mail and social medias to for the announcement. Thanks.
And I think I would just reiterate what Ryan so eloquently said in his presentation, that if anybody, especially people online, our colleagues that we have not yet had the pleasure of meeting in person yet, if you're interested in participating in a working group or a committee or anything else having to do with the IGS, you can feel free to contact us at the Central Bureau, or you can look up people's names on the IGS website. I know sometimes it can be rather intimidating to contact some of the working group chairs. They are truly celebrities in the world of geodesy, but I will assure you that each and every one of them is really happy to see new people come in and to try to continue to grow and expand our community. So just another encouragement that we would love to see more of you either online or in person, and that working groups are here for everybody. So thanks.
Thanks, Alison. So we are reaching the, what is called final comments and remarks, and well, this is exactly the message I wanted to insist on. We were talking about sustainability of the working groups, and in fact, this is needed. I mean, this is the sustainability of the entire IGS, which is in question. I mean, could we imagine a service without active working groups? I guess no. So this is something very important. And again, we'll repeat the message and invite people to join us. We need you. We need your help. We need your involvement in the working groups. I think this morning we had a great overview, even if it was short, but a great overview of all these activities we have within all these working groups. And I would like to thank again all the chairs who presented their work, and of course, thank all the members of the working groups. So thanks a lot again. I would like to thank the Central Bureau for organizing this meeting and all the support, the technical support. Thanks so much. And finally, thank all the attendees of the meeting in this room and online. So thanks again, and see you soon. Bye.